Hello बच्चों, let's read this question. The question says, if enthalpies of formation for C2H4 gas, CO2 gas and H2O liquid at 25 degrees Celsius and 1 atmosphere pressure are 52 minus 394 and minus 286 kilojoule per mole respectively, then enthalpy of combustion of C2H4 gas will be. So 4 options दिए गए हैं A, B, C and D, where A is plus 141.2 kilojoule per mole, B is plus 1412 kilojoule per mole, C is 141.2 kilojoule per mole, D is minus 1412 kilojoule per mole. So let's first understand the key concept involved in this question. So जो key concept involved हुआ है, it is using enthalpy of formation, which is represented by delta HF, enthalpies of formation values. So values दिए गए enthalpies of formation के values. So these values are used to determine enthalpy of combustion. Enthalpy of combustion. So let's understand what is enthalpy of combustion. Enthalpy of combustion. So enthalpy of combustion for a substance, it is the heat change when 1 mole of substance completely reacts with oxygen under standard conditions. So that means जब 1 मोल ऑफ सब्सटेंस completely ऑक्सीजन के साथ रिएक्ट होता है अंडर स्टैंडर्ड कंडीशन, उसको हम उसमें जो हीट चेंज होता है उसको हम हीट ऑफ एंथैल्पी ऑफ कंबशन और हीट ऑफ कंबशन बोलते हैं. So let's first we'll write the given data from the question. So we are given with enthalpy of formation of C2H4, that is ethylene in gaseous form का enthalpy of formation दिया गया है, which is 52 kilojoule per mole. Next जो value दिया गया है, that is enthalpy of formation of CO2 in gaseous form, which is minus 394 kilojoule per mole. Next we are given with the enthalpy of formation of H2O liquid, which is minus 286 kilojoule per mole. So these are the given data. First we'll write the combustion reaction of ethylene. Combustion reaction of ethylene, which is as follows: C2H4 ethylene in gaseous form reacts with 3 moles of O2 to give 2 moles of carbon dioxide gas plus 2 moles of H2O liquid. Now we'll use enthalpy of formation to write the enthalpy of reaction, that is delta H naught reaction is equal to summation of standard enthalpy of formation of products minus summation of standard enthalpy of formation of reactants. So using this, we'll calculate the enthalpy of formation of this reaction so that we can calculate the combustion of reaction. Calculate enthalpy change at products side. So that is, at product side we have 2 moles of CO2 gas. So 2 moles into formation of CO2 gas plus 2 moles into formation of H2O liquid. So this is the product side enthalpy change. If we substitute the values of enthalpy of formation, it will be minus 394 kilojoule per mole plus 2 into minus 286 kilojoule per mole. So if we solve this, it will come as minus 1360 kilojoules. So now we'll see the enthalpy change at reactant side. Reactant side we have 1 mole into delta HF, that is enthalpy of formation of C2H4 gas. So 1 mole into, if we substitute the value, it is 52 kilojoule per mole. So we are left with 52 kilojoules. So this is the enthalpy change at the reactant side. We have one more reactant, which is O2. So for that, enthalpy of formation of O2 gas is equal to 0 because O2 is in its already standard form. So already standard form है, that is O2 हमेशा gaseous form में पाया जाता है, so उसको form करने की जरूरत नहीं. Therefore, formation of that will be always 0. Now we'll calculate the total enthalpy change. Total enthalpy change for this reaction, that is delta H naught reaction is equal to summation of delta H naught products minus summation of delta H naught F reactants. So we have calculated both product side and reactant side values. So for the product side we have got 1360 kilojoules, and for the reactant side we got 52 kilojoules. So if we solve this, it will come as 1412 kilojoules. So based on this, we can clearly say that option D, which is minus 1412 kilojoules per mole, is the correct answer for this question. Hope you all have understood. All the best.